They've given us the speed of r and the mass of r and the final speed of r, and they've also given us the mass of s. And s is initially stationary. I'm assuming this because if s was moving this way or this way, then r would not change its direction here. So initially s is stationary. I can find the final speed of s by using m1u1 plus m2u2 should be m1v1 plus m2v2. And I can say that mass of r times initial speed of r. And initial speed is in this direction, it's to the right, so I've taken the right as positive, so this should be positive, plus the initial momentum of s, which is 0 because the initial speed is 0, times the final momentum of r, which is the mass, times, now here the direction is to the left, so the speed should be negative, and I've put in a negative sign here. Mass of r times the final speed of r, which is the same, but this time it's negative, so initial speed is negative and it's multiplied by the mass, plus the mass of s times this final speed of s, which we need to find. So I get x as 20 meters per second, -1. So the speed of x is 20, final speed of s is 20. And coming to the options in B, if you look at B, they say the change of velocity of s is 20. Initially s was 0 and it changed to 20. So the change of velocity s is 20, that's right. Therefore the answer is B. Now in A, they say that the change in momentum of s is in the direction of x. And that's not true, because I found the final speed of x to be 20. It's positive 20. If it was negative 20, then it would be in the direction of x. They've not told us what this arrow stands for, so this cannot be in this direction because final speed of s is 20. If it was negative 20, then s would be in this direction. So A is wrong. In C, it says that the change of momentum of r is 10 to the power of 3 times more than the change of momentum of s. You have the final speed and initial speed. You have the mass of r. You have the final speed, which is 20. You have the initial speed as 0. You have the mass of s, which is this. So you can find the change of momentum of s, and you can also find the change of momentum of r. And when you find both of these change of momentum, you're going to get the same value of 2 times 10 raised to power 31. And since both are same, there is no increase. That means this C is also wrong. Now, indeed, they're saying that momentum of r does not change. Well, initially it was traveling this way, and now it's traveling this way. It's changed direction. So momentum would be negative here because this speed is negative. So the speed is changing to negative. If they told us that the magnitude of momentum of r does not change, then we could say that D is right. But since the direction changes, we know that this D is not going to be true.